Alright guys, today we're going to talk about the normal curve. So this is going to be the last distribution we're going to be talking about. First is the normal distribution, so it's going to be very similar to the past few distributions where I'm going to give you some values, number of successes, things like that, and I want you to find the probability of that range occurring. That's the normal distribution. The next distribution is the inverse to the normal distribution, which means I'm going to give you percentages and I want to know at what value does it fall. So we're only going to be working with this normal curve from here on out, and I just wanted to talk about some attributes of this normal curve. So what we have here is the final version of what we learned when we talked about Chebyshev. Now if you recall, Chebyshev had his formula, and he figured out that within a certain number of deviations from the mean, a certain percent of the data should fall, or the probability of that range occurring. So after many years, they finally figured it out, and they came up with a more precise model. That's this normal curve. So what they decided is that it is symmetrical and bell-shaped, and the mean is always at the top, because this bell curve represents the probabilities of certain things occurring. So it would make sense that our expected, our mean, should have the highest probability of occurring. Now from there, if we go one deviation out, so I'm going to subtract a deviation and add a deviation, since this is symmetrical, I'm going to find 34% on either side of the mean. So that means that the probability of finding a value between one deviation below the mean and one deviation above the mean will be 68%. I'm going to go out to two deviations, and now the probability that a value will fall within two deviations from the mean is 95%, and then lastly, three deviations is going to be 99.7. Now this normal curve goes on forever, so we can go to negative infinity and we can go to positive infinity. Unfortunately, the 84s that we're working with can't comprehend the negative infinity and the positive infinity. So if we ever want to go to infinity or negative infinity, we just want to put in a really big positive number or a really big negative number. So that's the empirical rule. That is the final version of Chebyshev's. Now, when working with these probabilities, we're going to have three general options. The first one is called a left-tailed distribution. That means that we are going from negative infinity all the way up until a number. So if I wanted something less than, then that means that I want something less than a certain value. That's a left tail. If I wanted something greater than, then I'm going to start at this value and then go to positive infinity. If I wanted to be between two values, that will give me a center distribution. So some of the wording can get a little confusing in the problems because what they're asking for is a left tail distribution, a right tail, or a center, and all it means is that are you going from negative infinity to a number, going from a number to infinity, or are you going between two numbers? We'll break this down tomorrow when we go through some problems. Now the shaded region is going to represent our probability. So if I did the normal CDF and I typed in my lower and my upper bounds, so that would be the numbers or the infinity, which is a really big positive number, or the negative infinity, which is going to be a really big negative number, then I plug in the mean and standard deviation given in the problem, hit enter, and it will kick back the percentage that this shaded region represents. All right, last thing. We have two different ways to measure our values. So I was talking about deviations from the mean. Now, if I'm talking about deviations from the mean, I am talking about what we consider a Z-score. Now, a Z-score is just a fancy name for a standard deviation. Now, a standard deviation, as we've known it, has been 1, 2, or 3 set deviations from the mean. Z-scores can be any number. They can be 0.85, they can be negative 1.2. I can be any deviation from the mean that I want. That's a Z-score. Now, when working with Z-scores, we can always assume that we're going to work with something called the standard normal curve. The standard normal curve says that the mean is 0 and the deviation is 1. we don't actually care about the value that the mean or the deviation is. Much like percentiles, we want to know, in comparison to all the other values, how far above or below the mean does my score fall. I don't actually care about the score. I just want to know, am I above the mean, am I below the mean, and by how much? Now, if I did want to know the actual score, that's what we call a raw score, which is usually denoted from the variable x. That's the actual value of the data point. Now, in that case, they have to give you the mean or the standard deviation because otherwise you'd have no idea where your raw score falls if you didn't know what the average score was. Now, sometimes the book, which we're not going to go through all of this, but the book likes to give you raw scores and ask for z-scores, or gives you z-scores and asks for raw scores. On your formula sheet, you're given two formulas. This one says if you take the raw score, subtract the mean from it, and divide it by the standard deviation, you will get its corresponding deviation. So if the average is 80 and you scored a 78, you plug in the numbers here and you should be getting a negative z-score because the 78 is below the mean. If you scored an 85 and the average was an 80, you should be getting a positive z-score because you are now above the mean. Other way around, if you are given the z-score and you know the mean and the standard deviation, so you fell 2 deviations above the mean, that means that you were better than the average, so this raw score would have to be a number larger than the average. So that's just a way to go from raw scores to z-scores to raw scores, and back and forth. Tomorrow I'm going to give you some problems that are going to be talking about the empirical rule and using the normal CDF, and then we're just going to practice calculating some left tail, some right tail, and some center distributions. And then that's going to pretty much wrap up the week. And then next week we'll do the inverse norms. So take a look at this video. It's a bit of a lengthy one. It'll take about 5 hours to upload. So I will talk to you guys later.